What is going on, guys? Welcome back. In this video today, we're going to build a real-time e-commerce AI agent in Python. This essentially means an AI agent that uses real-time information from the web, not some past data, not some Kaggle data set, but actual information that is currently available online and up to date to find certain products that you specify in a prompt. So for example, you might be looking for monitors below a certain price point or GPUs with at least X amount of VRAM. Now, what you can do in this agent then is specify multiple platforms that you're interested in, and then this agent is going to go out there and scrape these platforms, look for information, real-time information, considering the current ratings, the current prices and everything, and then it's going to give you a list of results that you could be interested in. This is what we're going to build today, so let us get right into it. All right, now let us take a look at the final results so you know what you're getting yourself into with this tutorial today. This is the e-commerce agent, very simple as a Flask application. You can make this much more beautiful. You can add more features and more filters and checkboxes and everything if you want to. But the principle is it's just a prompt being sent to an agent, and these checkboxes are also just part of the prompt. So what we do is we specify what we're interested in, what we're looking for, something like, for example, top monitors below $200 that have 144 hertz, for example, and then I say I'm looking for Amazon, eBay, and Walmart, and then I can run the agent. And what this agent is going to do is it's going to take the data from the real internet, from the actual current state of the internet, and give me the products that are matching my criteria. So I have a language model behind the scenes, in this case GPT-4o, processing this and using tools. We're going to talk about these tools in a second here, but using some tools to retrieve data from the internet, and then it presents the results in the form of URLs and titles and ratings and so on. So I'm going to get here once the product search is done or the comparison is done. You can see it's still loading up here. Once this is done, I'm going to get a list of results, and these are going to be taken from the current internet, not from some old data set. There you go. We have Amazon, eBay, Walmart. We have 3 URLs per platform. I can just open these now. And you can also see I have information for or about the ratings. So here you can see 3,281 ratings. And if I go to the site, you can see it's the exact same number. So it's the current information up to date. And you can see 109.99 and also hopefully, is it 144 hertz? It's even more than that. So it's even higher than that. So that's fine. Down here, we have also the frequency that's required. The price is also fine. Then here's same thing, same, and so on and so forth. You can see that the products that I found here, or that the tool found here, match what I asked for, and it compares them across multiple platforms, or it finds them across multiple platforms. Of course, you can also easily implement comparison in your agent if you want to. And this is, of course, highly customizable. There's nothing preventing you from adding multiple other platforms here, or from introducing something like sliders for price ranges. You can do everything here in the UI that you want to, because at the end of the day, you're just sending a prompt to an agent, and the agent then uses the tools in a row to fulfill your request, to do what you asked it to do, and that's basically the whole magic. If you use checkboxes or provide everything here in the prompt, it doesn't really matter, but this is what we're going to build in this video today. So let us now get started with the implementation. For this, I'm going to open up my terminal and navigate to my working directory. And there are a couple of things that we need to take care of before we can start with the coding. One of them is we need to set up an environment file. And this environment file will have to contain a couple of things, because we're going to be relying on external services to make this work. On the one hand, we have, of course, the large language model, the backbone of the intelligence of the agent. But on the other hand, we also have the tools that we're going to use for scraping the internet. So maybe before we get started with the whole coding process, let me briefly sketch out the architecture of what we're going to build today in my Paint, just very, very briefly. The idea is not that we have one API that we're sending a request to and getting a response from. This is not what we're building today. What we're building today is we have our own AI agent with a backbone of intelligence, which is GPT-4o in our case, and a bunch of tools that this agent has access to. And these tools in this video today are going to be used for searching the web, for scraping websites, and everything that is somehow related to that. So also for certain platforms like Amazon, we have specific tools here for scraping Amazon and for finding products in Amazon. And what we're going to do now is we're going to send a request to this agent, and the agent is going to call multiple tools. So it's going to do that a couple of times back and forth, also exchanging this information with the language model. And as a result, we're going to get our structured output, which is JSON. Let's say, okay, it's not very beautiful, but a JSON object essentially, which we're going to render into a web page where we have all the links and all the descriptions listed. That is the rough architecture here. So again, we're going to need an API key for GPT-4o, and we're going to also need an API key and some variables here for these tools, because we're scraping real-time information from the internet. And this, of course, can be problematic if you implement it yourself with Selenium or requests or whatever. It's kind of difficult because a lot of websites don't allow you to, or make it very difficult for you to scrape them. You have CAPTCHAs, you have all sorts of things that make it difficult. They block IP addresses and so on. And this can be quite challenging, which is why we're going to use the tools from a company called BrightData. They are very famous for web scraping and proxy related stuff. They're also sponsoring this video, to be transparent with you. So let me just briefly pull up the web page here. Let me also close this MyPaint sketch. This is the company, BrightData, all-in-one platform for proxies and web scraping, and they have tools that we're going to use. And the cool thing is, I also have another video already that was sponsored by them. The cool thing is, in today's video, we don't even have to interact with their product at all. We don't really have to do anything. We don't have to use some SDK. We don't need to manually do anything. All we have to do is we have to connect their MCP server that provides all the tools. So MCP, for those of you who don't know it, is Model Context Protocol, a standardized protocol that makes it very easy to include functionality into existing agents, or also into Claude Desktop. This is also compatible with Claude Desktop. You can easily use these tools and these features from BrightData in your code by just specifying the MCP server. So we're going to do all of that, but first of all, let us install the packages that we're going to use. For this, you have two choices. You can go the classic route and say pip or pip3 install, and then all the package names, or you can use UV, which I'm going to do just because it's faster. You can use pip, you can use UV, it doesn't really matter. UV is just faster, so I prefer to use it. If you want to use UV as well, you say pip3 install UV, and then you say UV init to create a project in this current directory, and then you say UV add instead of pip or pip3 install. It's equivalent. You're not really gonna have a different program in the end, so just say pip3 install or UV add, and then we're going to install the following packages: python-.env for loading environment variables, including our API keys. Then also Flask for the web application, MCP for Model Context Protocol, LangChain, MCP adapters, LangGraph, and LangChain-OpenAI. Obviously, all of these are important for the agent. Now, if you want to use something else like Google Gemini models, you can also say LangChain, Google Gen AI or something. You can also go with LangChain Ollama or with LangChain Anthropic, doesn't really matter. Just install these packages. I think that should be everything. So just do UV add or pip3 install, and then you're good to go. We can start coding the application, except for we don't have the environment keys yet. Now, one thing that we need to do, of course, is we need to get our API key for OpenAI. What you have to do for that is you have to go to OpenAI API. You have to go to this platform here. You have to sign in, and then you have to go to your settings, to your API keys, and generate one. I'm not going to do that here now because it's something that you probably know how to do on your own. And in addition to that, this is not maybe as straightforward, is you need your BrightData authentication as well. So before we go into that, the structure is going to be the following. You're going to create a file called .env, like this, so .env. Now, in my case, I already have this file and it already contains all my credentials, so I'm not going to show it here in the tutorial. But let's assume that my file here is called .env.local or something, which is not what the name is going to be. It's going to be .env, but the file itself looks like this. You have the keys, for example, OpenAI API key. And then you have here the key whatever it looks like. So that is your OpenAI API key. And we're going to need a couple of other variables here, or a couple of other environment variables here as well. And these are going to come from BrightData. So you want to log into BrightData, you want to set up your account and everything. And then what you want to do is you want to go to proxies and scraping, and you're going to need two things. You're going to need an unlocker, so a web unlocker, and you're going to need a scraping browser. So you're going to go to add up here, and you want to create an instance of the web unlocker API, and you want to create an instance of the browser API. So these are going to be the two tools that we're going to use. And once you have them, you want to go to your specific instance here that you created. So for example, here MCP unlocker, and you want to use the URL for this. You want to use the zone here, which is the unlocker. So MCP unlocker is enough actually as an identifier. And for the scraping browser also, you want to use here the scraping browser. So these are the two things that you need to know about. And of course, the API key. So you also need to have an API key here. For this, you go to account settings, and then you go to API keys, and you just either copy the key, you create one, or you just refresh it, revoke it, whatever. You just need the API key, and then we're going to create our .n file, or we're going to extend our .n file by including all of that. So in my case now, what I'm going to do is I'm going to say web_unlocker_zone is going to be equal to, and it's going to be MCP_unlocker. Then you want to say browser auth, and here you want to now add the identifier for the browser. Now in my case, that is the following. It doesn't really matter because I'm not going to use this file. I already have this file prepared, but it would look something like this, where you have your URL here with scraping browser, and then finally you want to say API_token, which is going to be taken for BrightData. And here you just put your API key, whatever it looks like. That is what you need to have in your environment file. So in your .n file, you want to have the OpenAI API key for the language model, and you want to have these three things for the tools provided by BrightData. And then you can take this and turn it into an agent easily by just wrapping some LangChain and LangGraph stuff around it. So we're going to open up the app or actually it's called main.py. So let's maybe remove the main.py file and create a new file called app.py. And in here now we're going to build a simple Flask application that is a wrapper around the agent. So let us get started with the imports. We're going to import the core Python module OS for retrieving environment variables. We're going to import JSON. We're going to import also, by the way, I think I forgot one thing when it comes to the installation. We also need to install with uv-add or pip3 install. We need to also install Pydantic because we're going to do structured output. So uv-add Pydantic if I didn't do that before. Then we say here import JSON from typing. We want to import list and optional. And also I think we need to import async IO. So these are the core Python packages. Now for the installed packages, we're going to say from Pydantic import base model and field. This is for the structured output combined with the typing. Then we need to say from Flask import Flask render template redirect URL for and flash, and also request. Not request finish, but just request. The basic idea here being this is for the application, this is for rendering HTML documents, this is for redirecting to another route, this is for getting the URL for this other route, this is for flashing messages, so for getting messages when something succeeds or fails, and this is for handling details of the request. So just so you know what we're importing here. Then from MCP, we're going to import the client session, self-explanatory, the session for the client, and stdio server parameters. So standard input output server parameters. This is basically where we're going to put our MCP config. So this is how we're going to define the server from BrightData to connect to. And then also from mcp.client.stdio, we're going to import stdio client. Now, we also need to now add the LangChain stuff. So we're going to say from LangChain underscore MCP underscore adapters, we're going to import, or actually, sorry, from that dot tools, we're going to import the load MCP tool. So this is going to allow us to load the tools from MCP. Then also from LangChain underscore OpenAI, we're going to import the chat OpenAI class. So we have our model. And then from LangGraph, we're going to say from LangGraph.prebuild import create React agent. Now, this has nothing to do with the React framework with JavaScript or TypeScript. This is based on a paper. I think the paper is called React or Response and Act. What was it? Something like this. React paper. There you go. React, synergizing, reasoning, and acting. No, not response, reasoning, right? So synergizing, reasoning, and acting in language models. This is what React means in this case. Nothing to do with the JavaScript framework. That should basically be it for the imports. So again, we have this for structured output, this for the web application, this for MCP, this for the model, this also for MCP, and this is going to be for our agent so that we actually have an agent and not just a prompt being handled with tool use. All right, so the next thing is we need to load our environment variables. So we're going to say here load, oh, I forgot this one. From .env import load.env. So we need to load the environment variables. So load.env. This is going to load now all of the OpenAI key, browser auth, API token stuff that we saw a minute ago. Then we're going to take all of this and connect to the MCP server. Before that, we're going to say briefly model is equal to chat OpenAI, and the model here is going to just be GPT-4o, like that. And then we're going to define now the SDIO server parameters. We're going to say server underscore params is equal to SDIO server parameters. And then we're going to run this locally using the npx command. Now make sure you have this installed. I think if you have Node installed, most likely you have npx installed. Otherwise, just briefly go to Google, type install npx, your operating system, and you're going to find the instructions for that, but you need npx to run this. The arguments here are the following, just BrightData MCP, so at BrightData/MCP. And we need to provide the environment variables to authenticate ourselves with it. So we're going to say environment is equal to a dictionary. And here now we're going to say the API token is equal to os getenv API token. Then a comma, then copy paste this. And then here we're going to say browser auth. And here we're going to say web unlocker zone, and here the same thing. So this is how we authenticate this MCP connection, or how we get the tools, and how we also have the authorization to use these tools with our account by providing the general API token and by providing the scraper and the web unlocker that we're going to use to accomplish the task. So these are what allow us, or these are the things that provide the tools, and this is the thing that authenticates us. All right, so then we also need a system prompt. You can customize this to be whatever you want. In my case now, what seems to work best is the following. To find products, first use the search engine tool. When finding products, use the web data tool for the platform, and then if none exists, scrape as markdown. The reason I provide this here, and also I have an example, don't use web data best by products for search. Use it only for getting data on specific products you already found in search. The reason I'm saying that is because, of course, GPT-4o can be confused. It sees a bunch of tools. I think it's around 40 or 50 tools that we have here available. And it thinks, okay, I have to find products on Best Buy. So what I'm going to do is I'm going to use this tool called Web Data Best Buy Products, which works for getting information about specific products, but it doesn't work as a search engine. So actually, it can misuse this tool, which we don't want. So in order to specify this here, we can provide this as the system prompt. And these tools are available through the MCP server. You can find them on BrightData. You can also find them in Cloud Desktop, but these are some of the terms. Search engine is what should be used to find stuff. And then when we want to scrape something from a specific provider, we can do that using the individual tools if they exist. So that would be my system prompt. You can play around with that. You can change it. You can customize it to your specific workflow, but that is the general idea behind it. So this works for my use case here in this tutorial. Then what I'm going to do, and this is of course highly customizable, is I'm going to define the platforms. So what kind of platforms do I want to offer to the user? I can do Amazon. I can do Best Buy. I can do eBay and Walmart and so on. And you can enter here whatever you want. It's literally just a string, so you're not limited to these. I'm gonna just copy paste, or actually I don't have to copy paste, I can write them out. Target and Costco and Newegg. By the way, I asked ChatGPT for this because I'm not American, so I don't even know this one here. I mean, I've heard of these, but we don't have them here. Same for Walmart. I also don't know what Best Buy is. So as a European, I only know Amazon and eBay, and Walmart I've heard about. But yeah, these seem to be like the common e-commerce platforms that you would look for in the United States. And these are the ones I'm going to suggest to the user. Now, if you have, for example, a very specific agent that should be focusing on GPUs and CPUs, for example, or computer hardware, you maybe want to have some platforms here specifically oriented towards hardware and computer stuff. So maybe using Walmart and Target isn't the best idea in this case, but now we're going to keep it general, and this is what I'm going to offer to the user. Feel free to customize this however you want. Next up, what we need is the data model for the output. Now, in order to be able to take the response of the large language model and render it into our Flask application as HTML to show it as a list and to group it by company or by platform, we need to do this in a structured way. So we expect the output from the large language model to have a certain structure, so we can take that structure, iterate over it, and process it. So to make this possible, we're going to use Pydantic. We're going to define our data model using classes, and how we're going to structure this is the following way. I'm going to say I have the class, let's call this, for example, hit, for I found a product. So a product hit, which inherits from the base model. And for each hit, I want to have the information of the URL, which is a string. I want to have the title, which is also a string, so the title of the product. And I want to have the rating. And in this case, the rating is also going to be a string because I want to include here the rating in terms of stars, but also in terms of how many users have voted and so on. And what I can do now, in addition to just specifying the name and the type, is I can also specify a description by saying field, which is also Pydantic. So field ... and then description is equal to, and I can say something like, for example, the URL of the product that was found. Then here I can say description is equal to the title of the product that was found. So that's quite self-explanatory. The last one might be a little bit more interesting because here now I can say something like description, the rating of the product, stars, number of users or number of ratings given, etc. So this describes to the large language model what this field is for. So even if this field was called now XYZ, it would know that this is a field for the rating of the product. So it doesn't have to derive the meaning of the field by just looking at the name of the field. It can also look at the description. So this makes it easier for the product to give you a good response. So then for each platform, we can have multiple hits. So what I can do is I can say here, class platform block, for example, base model, and then I can say that a platform block consists of multiple hits. So I can say here, I want to have a string for the platform. So here I can say description, name of the platform, for example, and then I want to have a list of hits. So I want to say results is a list of hits. Now, I think that in modern Python, we could also just use list, like the basic list. I'm not sure about that. I think that's the case, so let's just try it. Maybe I'm wrong and we have to use typing, but I think that this should work. So I have a list of hits, and then I can say fields description is equal to list of results for this platform. And finally, we have our response object. So this is the product search response, which is also a base model, and it's going to consist of multiple platform blocks. So let's say platforms, which is going to be a list of platform block. And of course, it's going to be description is equal to aggregated list of all results grouped by platform. So that makes it quite clear for the model what it has to do. So this is what I'm expecting from GPT-4o as a result. And now let us get started with the functionality, because up until this point, we have just authenticated with the BrightData server, with the MCP tools. We have a system prompt, we have the platforms, we have the data model, but we don't really have any functionality yet. So what can we do? We can start by defining the Flask application with __name __, and we can also add a secret key. Why do we need a secret key? Because otherwise we cannot use flash messages. This is just because of the session. So we're going to say here my secret key or whatever, not for production. So just something so we can use the flash messages, and then we need a function, an asynchronous function for running the agent. So I'm going to say here async def run agent. It's going to get a query as input and the list of platforms. So basically our constant here. And then we're going to say here async with std IO client server param. So now we connect to the MCP server as, and we're going to get here read and write. So standard input and standard output. And we're going to take that and we're going to say here async with client session, given these buffers, I guess, or places to write to and read from. And then we're going to say as session or as sesh. And then we're going to say await session initialize. That's just a basic procedure. And now we can get the tools from this server. So now I can say tools that we have available is await, load, MCP tools, given the session, and then we can define our agent. We can say agent is equal to create React agent, and now we need to pass the model, we need to pass the tools, and we need to pass the response format. This is important because here now we specify that we want to have structured output. The final response should be a JSON object, of course not a string here, but the class. This is the product search response. So here we specify now that this is very strict. We want to have a product search response as output. So it uses GPT-4, it has the tools from BrightData, and it uses our data model that we defined, our schema, essentially. And then we can just say prompt is equal to, and now I can craft this however I want. In my case, what I did is I set query. Basically, the query is whatever the user specifies. Now, you can, of course, this is not secure. The user can type anything. It can completely mislead the model or the agent. So you maybe want to sanitize this. But in my case now, I just allow for the user query to exist here independently. And then I say platforms. Maybe let's use 2 line breaks, platforms. And I just use the platforms that were passed. So these can be all the platforms or whatever the user has checked. So you saw in the preview, we're going to have checkboxes where we can choose platforms. And this is what we're going to specify here. Now, of course, if you don't want to use the UI for that, you can just use the query and the user can specify manually. I'm looking for Amazon, eBay, and so on. But of course, making this into something more interesting can turn it into a SaaS product or into a side project that you want to use. So nowadays, the most value is probably created in the UI with all these AI wrappers. So just adding checkboxes and sliders and filters and all that is where the magic happens for most of these SaaS wrappers. So the least we can do is we can specify the platforms as checkboxes, comma, join, and here now platforms. And the result finally is going to be result is equal to await agent a invoke, and it has to be invoked on something. It has to be invoked on a dictionary object containing a messages key pointing to the message history, which in our case here is going to be the list of 2 dictionary entries. The first one being the system prompt. So we're going to say here role is going to be system and content is going to be the system prompt. And the second one is role user and the content is the prompt. That is actually the whole magic. You can use this already in the command line if that's what you wanted to do. Go ahead and do it. You don't even need the structured output, so you can just get the result and get the text out of the result. In our case, however, since we're going to use this in Flask, we need to get the structured object. So we're going to say structured is equal to result, and then there's the key or the field called structured underscore response. And this is then what we return. We say structured response dot model underscore dump. So that's going to be a Pydantic instance or instance of this class here. So we dump the model, we have then JSON, and that is what we're going to render into our Flask application. So that is, again, where the whole magic happens. This function here, if I zoom out, this run agent function together with this server parameters section and also with the model, this is where the whole magic happens. This is how easily you can integrate BrightData into your agent to scrape real-time information from the internet. That is the easiest way to do that. Everything we do from now on is just a web application around it. And so because of that, I want to speed up the process so you don't have to watch me now just do some basic Flask coding. I have multiple videos on this channel where I do that. What I'm going to do is I'm going to copy paste pieces of code. You can find all of this on GitHub, so you can also copy paste it from there if you want to. And I'm going to explain what I'm doing here. It's going to be quite simple. If anything's interesting, I'm going to elaborate. But the only thing we do here is a simple index route, so app route / the default route, allowing for get and post requests. We say here index. If the method is post, we get the query. The query is whatever it is, or it's just empty. Then we get the list of platforms. So it gets from the form here the platforms that are checked. And query is going to be the text that we provide in the text box. If any of these two are missing completely, we're going to redirect to the same endpoint, but we're going to say that we need a query or we need at least one platform selected. So that's quite simple. Then we're going to say try response JSON is equal to async IO run agent. This basically just means take this asynchronous function that we defined and run it given the query and the platform. So again, remember this takes query platforms. We pass it to that agent function and we get the result, which is the response JSON. If there is a problem, we flash, so we display the message that there is an error to the front end, quite simple. And in this case, then what we do is we render template index.html. So we're going to have our index.html file, which is going to have the Jinja 2 templating engine. So we're going to have some placeholders there. And we want to pass to it the query that was given, the platforms that were selected, or in this case here, the platforms that were selected and the platforms that were available, and also the response JSON, which is going to be rendered into the results. That is the post. For get, we're going to go outside of this if statement. So we skip this if statement, we go down here. And in this case, all we do is we just render exactly the same as here, but we have an empty query. We have no selected platforms and no response. That is our index endpoint, quite simple and straightforward. And then finally, we just say app.run. And we choose the host 0000, so we can run this on localhost and also on the private IP address. We select port 8000, debug equals true, and that is essentially the whole application. So the Flask part is quite simple and quite straightforward. Now we get to the HTML documents, which are even less interesting or less complicated. And for this, I'm going to create a new directory. So in the same directory where my app.py is located, I'm also going to create a directory templates. And in this directory, I'm going to create two files. One of them is base.html and the other one is index.html. Now, of course, you can also keep everything in a single file. This is just usually what you do. You have a base layout with the navigation and the header and everything, and then you have your other HTML files which extend that file. But essentially, this is the code for our base HTML. I'm going to, again, copy paste this because there's nothing really interesting here. We just have HTML, head, meta, title, styling. We have some bootstrap stuff here, some navigation, and some very basic content. The only interesting thing here is the flash messages. If you want to have the errors and everything here displayed, you do it here with the Jinja templating engine. Again, you can also just go with basic HTML. You don't need any styling whatsoever. You don't need anything. All you need is you just need the text box and the checkboxes, which are going to be in the index.html file, which looks like this. So here we have extends base HTML. Again, this is just taking this file and plugging in the content here from the index.html file. All of this is just styling again. Here we have the query. So here we have the actual input. You can see the important thing here is you want to have the named query, and you also want to have the value equal to curly brackets and then query, because what this does is it fills this input with the value if you already have one. So if you already have a value that was submitted, this is important because we have here for the index, if we post, we have query equals query. so that the text box still has the text in it. So that is what we accomplish here. And then what we do is we say select platforms. We have for platform in platforms, we just have checkboxes, and these have the IDs for loop.index. So they have just an enumeration here. And if they were selected, so if here in this post rendering here, if we have them as part of selected, they are going to be checked, otherwise not. And here again, the important thing is we want to have name platforms, because this is going to be treated as a list. So it's going to be aggregated essentially. That is the whole magic. Down here, we just take the response and we iterate over the top level. So again, we have here the product search response. So it's going to have a list of platform blocks actually. Then each of those is going to be platform and results, which is a list of hits. So you can see that here we iterate over the platforms. We show the string platform, we iterate over the results, and every result is just title, URL, and rating. Yeah, how you display that is up to you. You can have Tailwind, you can have Bootstrap, you can have a React frontend application. You just get this as a response, handle it however you like. This is very simple. Again, you can do copy paste from my code. You can write this yourself using no CSS, using just HTML, or you can also use Cursor or any other AI to style this however you want to. The basic principle is you need checkboxes, an input query of type text, and that is basically it. The other thing is just a submit button and rendering the results, iterating over them here with Jinja, templating engine. Whether you go with Flask, whether you go with Fast API, doesn't really matter. The magic happens here by including MCP from BrightData and by also wrapping this here in a LangGraph React agent. Now, one thing that I forgot to add here also is the styling. So we're going to create a directory static, and in this directory, we're going to create a file style.css. And we're just going to add some basic styling. Now, I noticed one mistake in my code here. It's of course not structured response model dump, it's structured model dump. So we need to get rid of this here. And then we can close this and we can say, in my case, since I'm using UV, I have to say UV run app.py. In your case, it would be Python 3 app.py if you're not using UV. So just running this now. And now I'm going to navigate to localhost port 8000, and we can type something in now like NVIDIA, or let's say find NVIDIA GPUs below $1,000 with at least 12 gigabytes of VRAM. And I want to do that on Amazon, eBay, Walmart, Newegg, and Target, for example. Run agent, and there you go. After a while, we get on Amazon here 2 results, on eBay 2 results, on Walmart 1, and on Newegg 1. So let's open them up and see if they are actually what we're looking for. So we can see here we have, I mean, I don't see a price because I'm not from the US, but at least we have here 12 gigabytes of VRAM. We have here 12 gigabytes of VRAM. The options seem to be from 348. 321. Here we have 265 for 12 gigabytes of VRAM. Then we have 589 for 12 gigabytes of VRAM here. And then we have 799 for 12 gigabytes of VRAM. And finally, we have $329 for 12 gigabytes of VRAM. So it fit the criteria. You can also see it's up to date. We have all these ratings here, 3,034 ratings. 3,034 ratings. We can of course ask stuff like give me more detailed information, list all the information, fill the data model with a price, with the, I don't know, with anything that could be interesting. If you're specializing this on GPUs, you can include a lot of stuff that is specific to GPUs, of course. You can also maybe add some flexible fields like extract the 3 most important attributes and you just have generic string fields that you can fill. So this is completely customizable. The important thing is you get real-time information from the internet. You can handle it using an AI agent without having to do anything yourself, not even calling the tools, not even prompting everything manually. You can just say, give me that on these platforms, and it will do that for you. And you can, of course, customize that however you want. So all of this done with BrightData, with LangChain, with Python, and with GPT-4o. And of course, as I said, BrightData is sponsoring the video, so you will find them at the link in the description down below, and you can sign up to do exactly what we did in this tutorial today. So that's it for today's video. I hope you enjoyed it and I hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching, see you in the next video, and